Welcome to the fifth video, 7-5. This is geometric sequences and series. We talked about arithmetic sequence and series, and we said that arithmetic is when you have a common difference. So, say for instance, if it's arithmetic, you would have a common difference, not a common ratio. And so, if you were adding, you would add 2 to each one. Remember we did that. But in a geometric, we're going to multiply. And so if I multiply, say r is equal to 2, then 2 times 1 is 2, then times 2, then times 2, then times 2, on and on and on. This would be very similar to what is shown here as an exponential. If I were to connect the dots, you can see that these, as x keeps increasing, you're going to be increasing exponentially to get this. So a common ratio could also be a fraction. Fraction is just division, and we know that division is really just multiplying by a fraction. So if I start with 1, this would be 1/2, then 1/4, then 1/8, etc., etc. And still is not linear. It is still exponential. In fact, geometric sequences are exponential. When you are trying to find the common ratio in a sequence, sometimes it's fairly obvious. Like in the first one, you can see that you're going to multiply times 2. The common ratio would be 2 here. But another way you can do it is take the second term and divide it by the first term, and you'll get 2. One thing you'll notice, though, is if you take the fourth term divided by the third term, you're still going to get 2. So there should be the same common ratio between all of the terms. All right, we're noticing here that the signs are alternating. And so if I take 22 divided by negative 11, I'm going to get negative 2. So when r is negative, the signs are going to alternate. That's going to be important. They alternate. Okay, so then this last one looks a little bit strange. So I have 8/3 divided by 4/1. And so 8/3 times 1/4, this cancels, and so my r is actually going to be 2/3, and then you try it. So 8/3 times 2/3 should be 16/9, is it? Yes, it is. Times 2/3 would be 32/27, yes, and so that works. So this is actually a decay exponential because r is between 0 and 1. This one, r equals 2, would be a growth. When r is negative, that is not exponential. It is not. R has to be positive. Here are the formulas used to find geometric sequences and series, and one thing I'd like to point out is to find any term, a sub n equals a sub 1 r to the n minus 1. Looks very, very similar to an exponential problem where this is the initial value, r is the rate, and then the exponent is time. So you're still looking at the exponential. Now this one, and I will give you these, most of them you'll have memorized just because you use them a lot, but to find the sum, the hardest thing here is to be careful of the signs and making sure that you're putting the parentheses around the correct thing. You can do these in the calculator, but be sure and put the parentheses, and there'll be some examples on the next screen. Find the common ratio for the sequence. I'm probably going to pick the second term and divide it by the first term, and that's going to get me negative 1/3, and that will be the common ratio. Find the common ratio for the sequence given this formula. All right, well remember this is a sub n equals a sub 1. I know what that is, that's 5. r to the n minus 1. So the r then is going to be 3, or in other words, it's going to triple. Here are some examples that you might find using geometric sequences. You want to find the 7th term of the sequence. So to find the 7th term, we know that n is equal to 7. We know the first term, that's 2, and now we just need r. we take 6 divided by 2 and get 3, so we have r is equal to 3. So to find the 7th term, a sub 7 is equal to the first term times the rate to the 7 minus 1 power. Put that in your calculator and you get 1,458. Do the same thing here for the 11th. N is equal to 11. A sub 1 is equal to 1. And r is going to be equal to negative 1/2 divided by 1. So r is just going to be negative 1/2. Put that one in. I have a sub 11 is the initial value, which is 1. I'm going to go ahead and put 1. R is negative 1/2 to the 11 minus 1 power, so that's the 10th. 2 to the 10th is 1,024. But because negative 1/2 to an even power is going to be positive, this is going to be 1 over 1,024. Last one. This one you got to be careful, and you really need to do the work to find r, because otherwise you'll get it wrong. When you look at it, don't you think this is times 3? It's not. All right, so n equals 8. A sub 1 is 1/2. I'm going to go ahead and put 1/2. To find r, I'm going to take 3.5. 3.5 is 7/2 divided by 1/2. So when you divide that, flip and multiply, r is equal to 7, not 3. 0.5 times 7 will get me that. So the decimal makes that look a little different, so be careful. Find a sub 8, 0.5, 7 to the 7th power, and that turns into something really big, 411,771.5. So be sure that you take the previous divided by the next divided by the previous to find r. Number 6 should look familiar. We looked at summation and sigma notation, and this is geometric. So if we're looking at this, we need the same things. There are going to be 5 terms. I'm trying to find the sum. So a sub 1 is going to be where I put 1 in there. That will be 3. The rate is 3 because it's tripling each time. And n is 5. So to find the sum, I find the sum sub n is equal to the first term, 1 minus r to the n over 1 minus r. That's the formula. All right, so s sub 5 is 3 times 1 minus 3 to the 5th power all over 1 minus 3. And to evaluate this, I would put this in my calculator first. I would put 1 minus 3 to the 5th power, hit enter, multiply that by 3, hit enter, and divide it by negative 2. And when you do that, you're going to get the answer, which is 363. Try that on your calculator, please, and make sure you know how to do that. Okay, number 7 is really important on here, and I would really like for you to pay attention, because one of the problems that you can have is when you have positive, negative, positive, negative. All right, so the same thing. We're going to find the sum of the first 8 terms. So I need s sub 8 is equal to, and a sub 1 is negative 5. Okay, so this is 1 minus, and this is 1 minus. So I have n is 8, a sub 1 is negative 5, and r is going to be 15 over negative 5, which is negative 3. All right, so here, when I put in r, I'm going to put in a negative 3 to the nth power, which is 8, and here, 1 minus a negative 3. Now, there's 2 different things going on here, so be careful. You cannot make negative negative as a positive here, because this whole thing is to the 8th power. So because this is even, an even power, this is actually going to be positive. So it'll be 1 minus whatever 3 to the 8th is. However, in the bottom, this is to the 1st power. So a negative times a negative is a positive. So on the top, I'm going to have 5 times something over 4. That will be 1 plus 3, which is 4. 1 minus 6561. And so your final answer for that is going to be 8200. Here's another type of problem that you might see. It says the third term of a geometric sequence is 3, and the sixth term is 1/9. Find the first term. So a good way to start here is to draw the situation. So I have 1, 2, 3. The third term is 3, 4, 5. The sixth term is 1/9. All right, so this is a sub 3, and this is a sub 6, and what I need to find is a sub 1. All right, so in a geometric sequence, I know that each one of the successive terms is found by multiplying the previous times r. So if I know what r is, I can work backwards and find here. So the key to this is to find r. So to do that, instead of starting at a sub 3 and go to a sub 6, I'm going to pretend that this is a sub 1, 2, 3, and a sub 4, and use that in my formula. I'm going to say a sub 4 is equal to a sub 1, r, to the 4 minus 1, which is 3. And I know what these are. So I know that 1/9 is equal to 3. I don't know what r is, but it's to the third power. So I'm going to divide both sides by 3, or multiply by 1/3. So 1 over 27 is equal to r to the third. And then I'm going to take the cube root of both sides. So r is going to equal 1 over the cube root of 27, which is 3. All right, so now I'm going to look here, and I'm going to see if this actually works. If I do 3 times a third, that gets me 1. 1 times a third is 1/3. 1/3 times 1/3 is 1/9, and so that works. So what would it be if I'm dividing, multiplying times a third to go this way, then I will be dividing by a third, right? So this would be 9, and then times 3 would be 27. So the answer to the question is a sub 1 is 27. So you can use this technique where you can show up anywhere in the sequence and start at a sub 1, go to a sub 4, anywhere in the sequence. And then once you have r, you can just work backwards until you get it. All right, on this final, part of your homework is to do this problem. So the ball is dropped from the height of 8 feet. That's a sub 1. And then the ball bounces to 80% of its previous height with each bounce. How high to the nearest tenth does the ball bounce on the fifth bounce? Okay, so you have to ask yourself, are you looking for the term, or are you looking for the sum? So I need to see your work, and when I check your notes, I'll be looking for this problem. So do not skip it, and I'll see you in class.